Today we're doing a dibenzyl acetone synthesis, which is actually a double aldol condensation. The first thing we're going to need for our stoichiometry is the masses of the two key reagents, the acetone and the benzaldehyde. So what we're going to do is we're actually going to reverse the order we put them in. We're going to weigh an empty beaker and we're going to add approximately 870 milligrams of the acetone, and before it has a chance to evaporate away, we're going to immediately put in the sodium hydroxide. So if you add 870 to that number, we're shooting for somewhere around 668.55, more or less. We'll stop when we're close to that number. The acetone is just boiling right out of my dropper. Don't even have to squeeze.
Yeah, organics have a tendency to kind of shoot out of the pipette. You got to be careful.
Okay, we're going to stop there. We're hoping, as the acetone's evaporating, quickly record the new weight, subtract it from the previous weight, and that will be your grams of acetone.
Not settling.
It's going down because it's evaporating. We're going to just say, right there, go.
Right. 0.5336.
Yeah, we're going to put in the acetone, or the sodium hydroxide. I already had it ready. Now we're going to weigh the benzaldehyde by difference. So,
Yep.
So I already put in 3 milliliters, which should be our excess reagent. You'll have to double check the math on stoichiometry. Remember, we have to use 2 moles of this for every 1 mole of that. And we're going to weigh this.
Are we able to close the lid?
Yeah, I'm going to close it.
Okay.
And it evaporates too. It smells like cherry cough syrup.
It's bitter almond.
Bitter almond, cherry cough syrup, same thing.
This last smells good. It's
Okay,
benzaldehyde, bitter
so
almond.
the number's going to keep going down. We'll pick a number right now, and I'll quickly pour it in and weigh it again. So,
Almost instantly going to precipitate there.
it's not going to, I'm not going to stir it yet.
Okay.
It will precipitate as soon as I stir. Hurry, we need this weight.
All right.
And then we can go back to the other thing. So this is the empty. The weight of the difference is our mass of the benzaldehyde. Okay, we now have all our weights. Let's start the reaction.
All right.
Okay, we now have the mixture of the benzaldehyde. It's already turning cloudy. Benzaldehyde does not like the aqueous solution, so we stir vigorously. And what happens is, when it does the mono-aldol condensation, just makes benzyl acetone, it makes first a white solid. We're hoping there's enough benzaldehyde to go a second time, and it will turn into a yellow solid. So what I always do is I stir it for a minute or two, and then I'm going to add the ethanol. So again, this is kind of like a reverse procedure. So now I've stirred it, it's starting to react. I can see the white solid forming. We're adding the ethanol, and it should now turn yellow. Or at least we hope it does.
We did.
Yep. And then it should start forming yellow crystals as we make more and more of the dibenzyl acetone. So again, the monomer product, which we don't want, is usually the white product. The dimer is a beautiful yellow color. We're getting a little bit of orange. That's a good sign. That's the benzaldehyde reacting with the impurities.
Wow. Pinkish almost.
Yep, always turns pink. We're going to remove those impurities when we do the...
Make sure you mention the observations. A lot of observations already.
Okay.
You can smell it too. It smells like almonds or
Yeah.
cough syrup.
It reminds me of cherry cough syrup. If you ever did arsenic and old lace, it reminds me of that too.
Did what?
Arsenic and old lace, where they did the almond cookies to kill off the men.
Wow.
It's an old black and white movie. Everybody should go home and see it. Okay, so I'm going to let that sit for a minute. We're supposed to let that react completely for about 15 total minutes.
So how would you describe that? Peach? Looks peach to me.
Yeah, it's a peachy color, kind of a mixture of yellow with pink.
It almost like it had an orangey hue there for a second too.
Yeah, that's the hue we'll get rid of. But it's reacting, it's looking pretty good. I'm just gonna let it sit. And we're gonna fast forward time for 10 minutes.
All right.
Okay, the reaction has run for a little over 15 minutes. If you look at the solid, it's basically a yellow color with there's a peachy cream liquid. We're now going to move over and filter, and I pre-prepared while the reaction was going 95% ethanol with a 1 milliliter glacial acetic acid. We'll use this in the filtration to try to neutralize any leftover sodium hydroxide in our crude product. Okay, we are now set up to do the filtration over in the Buchner funnel. I'm going to turn the vacuum on. It says to filter with ice cold water. We're going to use the water from our water bath because I use ultra pure water. And I'm going to take this out now. And we're going to transfer using our squirt bottle and the ultra pure water. This is for later, so save that right there. And if you look down inside, you'll see it's a lovely yellow crystals. We made a lot of product here. Can you see that?
Yep. Got better.
And it's nice yellow.
Looks like mashed potatoes.
Very buttery mashed potato. Okay, so we're going to, suction's on, check. We're going to filter right down the center of the filter paper as best we can. Remember, we don't have to take it all out if we don't want to because we're going to recrystallize right back in the same beaker. And that way it'll maximize our yield. Okay, but the goal is to remove all the sodium hydroxide and any of the other solvents. So we're going to add a little water, swirl it around. This is ice cold water. And the main goal, again, is to remove the soluble sodium hydroxide, pour it over the top. We have a nice yellow residue, that's good. I'm going to do one more rinse. And then I'm going to turn the vacuum off after I spread out the solid just a little bit, because the next step is to do that soak. And the soak is to, again, to remove any sodium hydroxide that might be trapped in our solid.
I just want to show them the color of the filtrate.
Go ahead.
Yeah, most of the pink went down here, guys.
That's where it's supposed to go.
And then this part stayed mostly yellow.
Yep. Okay, so turning off the vacuum. We're going to pour this over the top. Just let it sit there. Okay, and we're going to let it soak for about a minute. How long can you hold your arm there?
I probably could, but I'm going to cut.
Okay, we've let it soak. It's time to turn the vacuum back on. Watch it to stop dripping. At the bottom, remove, only takes a few seconds. Once it stops dripping, we're going to turn off the vacuum and transfer all of our crude product back into the original beaker. And we'll start recrystallizing with boiling ethanol.
Looks like egg yolk now.
Scrambled eggs?
Yeah.
Okay. That's enough. I'm going to move on. Okay, so next step. You can take off the top of the Buchner funnel. And the procedures tell you to do this, but I always like to try to knock in as much of my product as I can. So I'm going to change this to there. So that was most of it. Went back in the beaker. And then we're going to grab the filter paper with tweezers and set it on the edge, just like I did last lab. And hopefully it'll stick to the edge this time.
I wrote these soaks into the new procedures.
Yeah, you said to soak it. I like to squirt it off. Okay, so again, I'm going to scrape out as much of the solid as I can. I will also do a recrystallization rinse of this Buchner funnel to try to remove any of the crude product as possible before, and then I can reuse the Buchner funnel for the final filtration. Okay, so next, right next to it, I've already started boiling the ethanol. See, the ethanol's boiling. I'm going to take the dropper. Be careful because it likes to shoot out. First thing I'm going to do is clean out my Buchner funnel. Remove as much of my crude product as I can. See how that looks. I'll do one more rinse. Okay. So that looks good there. Put the Buchner funnel back. Okay, now to remove the paper, we're going to try to rinse off all of that yellow. So you see how the yellow kind of immediately dissolves right off the paper when I squirt the boiling hot ethanol on it? That's what we want it to do. Actually, I'm going to rinse off my forceps for a second, or tweezers, whatever you want to call these. Come on, tweezers. If I end up with any red, it's from the tweezers. It looks like there was a little rust spot, so we're going to ignore that rust spot. Okay, squirt off that yellow. There's another spot over there. That's looking pretty good. Check the back side. It didn't fall very far. Okay, this is why I like to use fingers. Okay, there is a couple yellow spots. I want those. So don't lose any of our product, because we're going to just throw away this piece of paper when we're done rinsing. Okay, how are we doing? Looking pretty good? Okay, so this goes into the trash. I'll just set it here for now. I want to go to the next step, which is remove the stirring rod. Same procedure. Rinse it off until all the yellow comes off. Okay, that looks pretty clean. I'll put that over there for now. And now I have some liquid in here. I'm going to switch places and start rinsing down the sides of my beaker, especially around the spout where all the solid came out.
And it should all be yellow at this point, right?
Yep, we should. So when you recrystallize, remember the rules. We want a solvent that will dissolve it when it's boiling to a nice clear yellow liquid is what we want. But when we cool it in the ice bath, the crystals will come back. Okay, and if you use too much solvent, that looks like enough solvent. I'm going to wait for that to boil. If you use too much solvent, you'll lose some of the product in the final filtration, kind of like what happened last time. So, okay, we finished boiling it, and we have this lovely clear yellow liquid. We now need to let it cool down slowly before we put it in the ice bath so that it can grow perfect crystals and we can have a near perfect melting point. We're going to use our melting point for our purity test today after we obtain our yield. But right now when I touch the beaker, it's still quite hot. Although if I look inside, I see that there's already crystals forming. They're kind of white and floaty. And so I'll tip this back up, and I'm going to let it just keep cooling until it feels like it's at room temperature. And all the while it's growing crystals. We're letting it grow nice and slow and make ultra pure crystals. There we go. All right, class, we are basically down to room temperature. You're still recording?
Yeah.
We're going to now put it in the ice bath for 5 minutes, and this was to obtain our maximum yield possible. We'll just let that sit. And while that's sitting over there, we'll prepare another piece of filter paper for the final filtration. And we're going on a side camera, go pre-weigh a watch glass.
Yes, I play in lab. Don't judge me.
With no gloves on.
With no gloves on.
Now let it ice for about 5+ minutes. We have a nice layer of crystals in here. So we're now going to filter using a little bit of ice cold ethanol to rinse and to wet down our paper. So first I'm going to wet down the paper. Okay, I'm wetting down the paper. Turn on the vacuum. And now to try to transfer all this beautiful sparkly yellow crystals into the middle of our filter paper. Okay.
Purified scrambled eggs.
Now these are ice crystals like lemonade. Now.
Okay. It's like the concentrate for the juice.
Yeah, kind of like the lemonade concentrate. That's what it looks like to me. Just a nice clearish yellow crystal. Okay, so you see we still have a fair amount of product left in the beaker. So we're going to try to do both our rinse and to recover product as best we can with some ice cold ethanol that I pre-iced while I was waiting. So I'm going to roll this around and knock off all the edges.
Professor, why should we use cold ethanol and not hot ethanol here?
I answered that last time, but the answer is as long as it's ice cold, it'll dissolve less of our product and hopefully we'll obtain a higher yield this way. And this was sitting in the ice bath before I started using it. So let's pour it. And there, we got a lot of it. We're going to do one more rinse. Set this right here. Again, ice cold ethanol. And even though it's ice cold, you notice that the liquid turned a yellow color. That's some of our product dissolving away. But we're not going to Okay.
You always lose a little bit in the recovery
So
process.
I'm not going to do any more rinses because, well, there's one more piece. I'm going to get that piece. That's on the outside. I'm not going to get it. So we're going to do our yield with what's in here. And it looks nice and bright yellow and sparkly. Everybody see that?
You get really close for that.
Okay, let's go really close and make sure we have some light.
That's great.
Okay. There we go. You can even see the sparkles in the corner. Yeah, so this makes a bright, sparkly yellow. The ethanol is going to take about 15 minutes to evaporate while we're under full suction. So we're just going to take a break.
Yep.
As you see here, we have vacuum dried and we have our purified product. We now need to weigh it. So we need to first pre-weigh the watch glass. Record its weight when it stops moving.
This one shouldn't fluctuate as much as the last ones were.
Yeah, we don't have evaporating liquids. There we go. Now we're going to carefully transfer all of our product onto the watch glass. We're going to remove the filter paper if it falls out. Sorry, I'm not showing it very well. Okay. So there's a little bit stuck on the filter paper. I'm going to knock that off because this is our yield now, from which you will be able to calculate your percent yield, assuming you correctly calculate your theoretical yield from the two reagents. So I can't see when I do it backwards. Okay, so we left a tiny bit behind, but it probably weighs less than 1/10 of a gram, maybe even less than 100th of a gram. So we're not going to go for that last
I want to
milligram.
add something when you do this real quick.
Go ahead.
If you're in my section, I want you to calculate the theoretical yield, treating them both as limiting reagents, and figure out which one is actually limiting.
Same with mine.
Okay, so both
The
of us then.
reason we weighed both of them is because either one can be limiting. Remember, the mole-to-mole ratios are not all 1-to-1. That's my hint.
Yep. Look at this.
Okay.
Look at the stoichiometry. Not 1-to-1.
So our final product yield with the watch glass.
All right, I think we finally settled. We're getting close to it.
Record it.
All right, let's go ahead and take 55.4530. All right. All right, everybody, we're at the moment of truth. Let's see if Professor Hammond did a good job today. So we only have one sample today. It's just the purified dibenzyl acetone. Is that right?
Dibenzyl acetone.
Yeah, dibenzyl acetone. The expected melting point is about 113. So am I starting at that 100? Oop. All right, let's go ahead and start it.